In this problem, we are asked to find the antiderivative of the sine of log of x. When we look carefully at the function sine of log of x, the first thing that comes in mind is that this function is a composition of two functions, the sine function and the logarithmic function. This suggests that we should first start with the u substitution method. It is evident that the natural choice for the parameter u should be the inner function. Thus, u should be log of x. We set u equal to log of x, then du equal to the fraction 1 over x, and more importantly we note that x equal to exponential of u. The integral of sine of log of x dx can be expressed as the integral of x times sine of log of x times 1 over x dx. We can clearly see u and du in the expression of the integral. So, we replace log of x by u and 1 over x dx by du and obtain the new expression of this integral as the integral of x times sine of u du. This suggests that we have to replace x by its expression in terms of u. But we know that x is exponential of u, therefore, the new expression as the integral of exponential of u times sine of u du is. In order to compute the integral of exponential of u times sine of u du, we have to use the integration by parts method. Recall the integration by parts method. In this new approach, we set v equal to sine of u and dw equals exponential of u. Thus, dv equals cosine of u and w equals exponential of u. Therefore, the integral of exponential of u times sine of u du is equal to exponential of u times sine of u minus the integral of exponential of u times cosine of u du. We see that we still have to simplify the integral of exponential of u times cosine of u du. As a matter of fact, we will still use the integral by parts to simplify this integral. Once more, we set v equal to cosine of u and dw equal to exponential of u. Thus, dv is equal to negative sine of u and w is equal to exponential of u. It comes that, the integral of exponential of u times cosine of u du is then equal to exponential of u times cosine of u plus the integral of exponential of u times sine of u du. We then combine equation 1 and equation 2 and we see that the integral of exponential of u times sine of u du appears on both sides of the new equation. We move those terms on one side. When we solve the resulting equation, we see that the integral of exponential of u times sine of u du is equal to 1/2 times exponential of u times the quantity of sine of u minus cosine of u, plus the constant c. In sum, the integral of sine of log of x is equal to the integral of exponential of u times sine of u du, which is equal to 1/2 times exponential of u times the quantity of sine minus cosine of u. When we replace u by log of x, we have the final expression of the antiderivative as 1/2 times x times the expression sine of log of x minus cosine of log of x, plus the constant c. Thank you for viewing this video. Please subscribe to our channel. We have an extensive collection of calculus-related videos covering limits, derivatives, integration, and many other calculus topics.